Okay, I'm recording now. Perfect. So I'm gonna just remind you very quickly what's an exponential function, what's a log function, and then we're gonna have a couple of exercises, see how to compute the log, log of a number, without, of course, without calculators, we will solve some exponential and log equations. So yeah, so first let me remind you definition of exponential and log. So let me start with the exponential. So we said, this is first definition one. This is the definition of exponential. So an exponential function is a function of the form. So an exponential function is a function of the form so it's of the form a to the x. So f of x equal to a to the x so where a so the number a it's a constant. It's called the base of the exponential. So this a, so where a is a positive, so a has to be is a positive is a positive number, positive real number, different from 1. Okay. And as I said, so a is called the base. A is called the base of this exponential. It's the base. All right. And I think I gave you a couple of examples, but what you need to keep in mind, guys, is that a can be a fraction, can be a decimal. It doesn't have to be like a whole number, right? It can be a fraction, can be decimal, can be anything. Of course, it has to be positive, different from 1. All right, so that's for the exponential. And then I think I introduced the logarithmic functions. And I said, by definition, logarithmic function is just the inverse of the exponential. Oh, Eric, I got you. Thank you. Thank you. Yeah, so for x positive, you need x positive, guys. So this is really important for x. When your x is positive, the inverse of f of x equal to a to the x is g of x equal to log. So this is log in base a of x. Okay. So first, guys, so what you need to understand here is that first, this is log of x. Okay, so you see the space between the log and parenthesis x? That's not like log times x. This is log of x. So you cannot separate the log from x. It's log of a number. Log of a number would be a number, but just log, it's nothing. It's just a function, right? So here it's off, right? Between log and x. So that's log of x. Okay, so when you cannot separate the log from x. I mean, log of let's say in base 2 of phi. This is not like log in base 2 times phi. Okay, that's not true, right? It's log of the number phi. So you cannot separate the log from the phi. Okay, they come together, the log and the phi. Because I know, I mean, this is like a kind of a common mistake. People think like you can separate the log from the x. That's not true, right? So a log of a number is going to give you another number. Okay, but log just itself is just a function. It doesn't mean anything. Okay, you have to apply it to some number. Yeah. So what I'm going to say next. yeah, so this is so that's the definition of log. Okay, it's just the inverse. We discussed the inverse function in I think in section 1.8. So log by definition is the inverse of the exponential. Now, what's the consequence of this definition, right? What's the consequence of the fact that log is the inverse of exponential? So the first important consequence is the following. Let me just erase this remark here. And then I'm going to compute the log of some numbers. All right, so the first, and I would say the most important consequence is the following. So first consequence number one. And this, again, this just follows from the definition, right? So if you have like y equals to log in base, let's say a of x, then this is actually equivalent to, okay, so this is equivalent to b or a to the y. So then a to the y is equal to x. All right. So this is a consequence of the definition. This is because log is the inverse of the exponential. So for example, so a couple of examples. So example number one. So let's say you have log. So y is equal to log log n base, let's say 7 of 49. Okay. So the base here, your a is the 7. Okay. And your x is the 49. Okay. Then because of the first the consequence number one, as you can see here, then a to the power y would be equal to x. Okay. So in other words, a is 7. That's my base. Y, of course, is unknown. I don't know what's the value of y yet, right? So then 7 to the power y is equal to x, and x, of course, in this example is 49, right? So the question here is, for which power of 7 to the y would be 49? So for which power of y you get 49? Then you need y to be equal to 2, right? So this y here, y would be 2, right? That's 7 squared would be 49. So the answer, log in base 7 of 49. So log in base 7 of 49 would be equal to 2.
Is that saying that how many times 7 times itself would give us 49? That's what,
yeah, absolutely.
That's the logic of this. Okay,
yeah.
okay.
Yeah, it's I mean 7 to the power y, so it's like 7 multiplied by itself, like y times. So this is like 7 times 7 y times. And of course, to get 49, you need to multiply 7 by itself 2 times, right? Yeah. So yeah, another example. Let me do another example number 2. So let's say again, y equal to log in base, let's say 2 of 1/8. Okay, so then the question is, for which power of, so the base here is 2, right? The A is 2, right? So for which power of 2, you're gonna get 1 over 8, right? So this is, again, this is like my X. So then, as I said, because of our identity, right? And then, you know, you need A to the power Y to be equal to X. So then A to the power Y is equal to X. And so, yeah, A is 2, Y is unknown. And then X, of course, is the 1 over 8. So for which power of 2, guys, we get 1 over 8? Negative V, Richmond. Yeah, absolutely. Thank you. So, so then the Y here would be negative V, okay? Because when you do 2 to the power negative V, 2 to the negative V. Now, when you have a negative power, guys, it doesn't mean you're gonna get a negative number. A negative power, if you wanna change the negative power to a positive power, you need to divide by, so you need to flip. So it's like 1 over 2 to the power positive V. This would be positive V. Okay. So then, of course, 2 cube, or 2 to the power positive V, that would be 8. So that's 1 over 8. Okay. So whenever you have a negative number, guys, just flip, and that will be, if you move the negative power to the bottom, that will be positive power, right? This 2 to the power negative V is like 2 to the power negative V over 1, right? So what I did actually is I just flipped the fraction. So when you flip a fraction, the powers change their sign. Okay, so if you have like a negative power and you flip, then that will be a positive power.
You know, Wicked, the dude I've been making music with.
Okay, I guess I need to mute someone. Right. All right. So what else?
Professor, I have a question.
Yeah, please.
1 over 2 plus 3, that's supposed to be 5. How did you get the 8?
No, it's not 2 plus t. That's 2 to the power t. That's 2 cube. This is 2 to the power t. So that's like 2 times 2 times 2, 3 times.
So why did you put plus 3 over there? To say that it's positive.
The positive t, that's because, as I said, so you see the negative t right here. Okay, that's a power negative t, right? So what I said is, so when you flip, when you move a power, like so this power here is like in the top of your fraction, right? You have this fraction which is like 2 to the power negative t over 1, right? So when you move your power, or your power to the bottom, if you flip your fraction, then the negative becomes positive. And if you had like positive, then when you flip it, then becomes negative. Okay, so if you move a power, like you have some power in the top and you move it to the denominator, then the power becomes positive. Or the other way, if it's positive and you move to the bottom, that will be negative. So you need to change the sign of the power whenever you flip a fraction. Make sense? Okay, so it's yeah, it's so what I'm saying is, so let me just give you another example. So let's say you have like 5 to the power negative phi over phi to the power positive 4. Okay, so if you flip this fraction, so if you move this 5 to the bottom, then that will be 5 to the power positive 2. Okay, and if you decide, for example, to move this phi to the power 4 to the top, that will be phi to the power negative 4. So whenever you move like a power either to the top or to the bottom, you have to change the sign of the exponent. You see what I'm saying? So then, like, you have this 2 to the power negative phi, right? So this is like 2 to the power negative 3 over 1, right? Because when you divide by 1, it doesn't change your number. But then if you move the power to the bottom, or if you flip your fraction, so then this 2 to the power negative 3 becomes 2 to the power positive 3. Okay, makes more sense now.
Yes.
Okay.
Well, I'm sorry. I don't particularly
yeah.
understand why we're flipping it. Like if
No, just because when you have like a negative power, and we don't like, let's say, negative powers, right? And you want to change it to a positive power. So that's why I flip it.
okay, so here's another question then. If I have a
Yeah.
fraction, right?
Yeah.
Is it always a negative power?
No, of course, if you have a fraction, it could be positive. You can have positive power or negative. But what I'm saying is, whenever you move your power, like if you move like from the top to the bottom or from the bottom to the top, then you have to change the sign of the power. Okay, so if you have like positive power, like 2 to the power phi, okay, then again, this is just 2 to the power phi over 1. But then if you move this to the power phi to the bottom, that will be 2 to the power negative phi.
Well, that's what you want because you have the 1/8, though, right?
Yeah, in some sense, yeah. Because
So
no, but you know, in my example, I had 2 to the power negative phi, right? And I want to compute this thing. Okay. I mean, if it was, of course, 2 to the power positive phi, then I know it's like 2 times 2 times 2, 3 times, right?
mhm.
Now I want to compute this thing, this 2 to the power negative phi. And the way to do it, because I don't know really how you know, compute the number with the power with negative exponent. So what I'm gonna do, I'm gonna just you know, flip in some sense my number, and that'll give me a positive power. So like this 2 to the power negative phi, as I said, you can write it as a fraction by dividing by 1, and then you flip. So when you flip, that will be 2 to the power positive 8. So that's the 1/8. So the thing is, I want to compute this number here, the 2 to the power negative 8. And to compute a number with a negative power, the idea is to move your number. So if it's like in the top, you need to move your number to the bottom. So that will give you like a positive power. If your number is like in the denominator, then you have to move it to the top. So then you can get positive power, right? So all I'm saying is, whenever you see a negative power, just move it. I mean, if you see like a negative power like in the top, move it to the bottom. So that will be a positive power. And if you see a negative power in the bottom, move it to the top, and that will be a positive power. Okay, but here again, my goal is to compute this 2 to the power negative phi. And the way to do it is, as I said, you move it to the denominator, and that will give you a positive power. And I know how to compute 2 to the power positive phi, right? That's just 2 times itself 3 times. Okay. Well, one more example. Example 3. So let's say y is equal to log in base.
Professor, I have a question.
Yeah, please.
You wrote, what's it called? Example like 5 raised to the power negative 2 over 3 plus 4. What does that have to do with the 2 over
No,
3?
this example, no, I'm just trying to explain, you're talking about this example, right? So I'm just
Yeah,
trying
what
to
does that
explain
have to
if
do with the one on the bottom?
this one here, no, that's a different example. It has nothing to do with the next. But all I'm saying is, so you see here this 5 with a negative power in the top. So when I move it to the bottom, it becomes positive too, right? The power becomes positive. And here, I had like positive power and I move to the top, then it becomes negative. So all I'm saying is whenever you move your power to the bottom or to the top, then you change the sign.
Okay.
And that's, I
Yeah.
apply the same thing to this 2 to the power negative phi, right? 2 to the negative phi. Let me just write it again. Sorry about the mess, but so what I'm saying is I want to compute 2 to the power negative phi. I don't know what's 2 to the power negative phi, right? So I know what's 2 to the power positive phi. 2 to the positive phi, I know it's 2 times 2 times 2, 3 times, right? But I need positive phi, not negative phi. Now, the idea is, to change the sign from negative phi to positive phi. And to change the sign of the exponent, you have to move it. Like if it's in the top, you have to move to the bottom of your fraction. And if it's in the bottom of your fraction, you have to move to the top. So here, there's 2 to the negative phi. I mean, of course, it doesn't look like a fraction, but it's a fraction because you can just divide by 1. Now it becomes a fraction. And when you divide by 1, of course, it doesn't change the number. But then, and now I can move it to the denominator, this 2 to the power negative phi. So if you move it to the denominator, now it becomes positive phi. And I know what's 2 to the positive phi. That's 8. That's 2 times 2 times 2, right? 3 times. I know what's this number. That would be 8. Right? So the goal, of course, was to compute what's this 2 to the power negative phi. All right, one more example. So let's say y is log in base, let's see. Yeah, so for example, let's say here it's phi, oops, sorry. So here it's phi, and here it's, let's say 1/9. So again, the idea is, so this is your base A, this is your X, and so this is equivalent to your base, which is A to the X equal to Y. So then A, which is the X, sorry, I should probably, what else here? Yeah, so instead of, no, this is a really bad example, I guess. Where is it? My previous example was, I mean, yeah. Sorry. So, well, it's fine. It's a good example. So yeah, I was saying, so this is, sorry, this is A to the power Y, I mean, sorry. This is A to the power Y, A to the power Y equal to X, okay? And so the question is, for which power of phi you can get, so phi to the Y equal to X, X is 1/9. Okay, and yeah, so the question is, for which power of phi to the Y would be 1/9. And again, the idea, guys, is that, I mean, I know phi squared would be 9, right? Because it's 3 times phi. Because, phi times phi, it's 9, right? But here, it's not 9, it's 1/9, right? It's 1/9, right? This is 1/9. And so the idea is, well, if you have 1/9, right? Because 9 is 3 squared, that would be 1/3 squared. But then 1/3 squared, as I said, if you, yeah, Shakwan Richmond, thank you. So if you move this 3 squared to the top, that will be phi to the power -2. Okay. So this Y here would be -2. Okay. Again, the idea is that, so the 3 squared, I know it's 9. It's not 1/9, it's 9. Now the thing is, if you want 1/9, then it's 1/3 squared, and then the 3 squared would be in the denominator. But if you move it to the top, that will be phi to the power -2. Okay, so this is phi to the power -2. So then your y, so to answer this question here, log in base phi of 1/9 would be equal to -2, because phi to the -2 is equal to 1/9. So again, this is your a, this is supposed to be your x, and this is supposed to be your y, right? And this is a to the power y is equal to x. All right, so one more example, or
Wait, don't go too fast. Don't go too fast now.
okay. 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 One last example, and then I will give an exercise so you can practice a little bit. So last example. Example 4, which is kind of different from the previous examples. All right, so this is not this is less obvious than the previous examples. So let's say you have again y, right, log, and now I have, let's say, 2 log in base 2 of 5. Okay, and we want to compute this y, right? So the question is, what's y? Okay. So, I mean, this is less obvious because, so in this case, what we want is, again, this is supposed to be your a, this is supposed to be your x, and then we're supposed to have like a to the power y, for which power of a, you're gonna get 5, right? So then, your a is 2, so then you have this power y, equal to 5. Okay. So then you can see here why it's not, it cannot be a whole number, right? I mean, 2 squared is 4, and sorry. So 2 squared is 4, and 2 cubed, or 2 to the power 3, that's 8, right? So in other words, your power y, it's just some number between 2 and 3. It's not a whole number, right? So y is because it's 2 to the power y is 5, right? And then what we are saying is 2 squared is 4, 2 cubed is 8. So y, it's like a number between 2 and 3. So y is between 2 and 3, right? So it's not a whole number, right? So log of a number, it doesn't have to be like a, it doesn't have to be like a whole number. It can be a fraction, it can be a decimal. Okay. So then, of course, so how do we compute such y? Well, then you're gonna need actually a calculator. Okay. But of course, so then we need, it's going to be a number, some number between 2 and 3. Then we're going to need a calculator. To compute this log in base 2 of 5. Okay. So all I'm saying, guys, is that log of a number, it doesn't have to be a whole number. It can be some decimal, it can be a fraction, it can be any real number, actually. Anyway, so so here's an exercise for you.
So I'm sorry, excuse me.
Yeah,
So what do we do when we get this problem? Is it like undefined, or is it like?
No, it's not undefined. As I said,
So what do we call this instance?
So it's not undefined. So it's going to be some decimal. some number between, as I said, between 2 and 3. And actually it's going to be 2 point something, but this is, so this log, so log in base 2 of 5. So as an answer, I'm just write it here, 5. So this is going to be a real number between 2 and 3. But to find this number, you're going to need a calculator. Okay. It's well defined, right? This is well defined, but we just need a calculator to find this number. Okay. It's a number between 2 and 3.
Okay, so I shouldn't have to really worry about it then.
No,
for
no.
Final then, right?
Yeah.
Okay.
You don't have to worry about it. Yeah. All right. So yeah, let's practice a little bit. So exercise. So please try to compute the following. Let's see. Okay, so 1, 2, and the 3. Okay, so y equals to, so compute y, of course, log, let's say in base 2 of 16, y log in base 3 of 1 over 81, let's say, and then y equal to log base 4 of 1 over, yeah, let's do 1 over 16. 1 over 16. Yeah, let me just say one more thing, guys. I mean, to compute this number, we can change the base, and I'm going to show you later actually how to compute such number when you change the base. So there's a way to change the base, and then you'll be able to compute such a number. But anyway. Richmond, you're saying number 1, it's 4, absolutely. Number 2 is saying -4. Yes, you're right. Thank you. Absolutely. And number 3, it's -2, -4. No, for number 3, it should be -2, not -4. I guess you mean -2 for number 3, right?
Professor,
Yes.
you
Yes,
said
please.
number 2 is -4.
Yep. Number 2, it's -4. Yep. Louis, you're saying -2 to the power
Professor, I
4.
don't think so. Because 4 raised to the power, like 3 is going to be 64. not 81.
You're talking about number 2, right?
Yeah,
But number 2, the base is not 4. It's the base is
3.
3. Yeah.
Yeah,
Yeah. So 3 squared would be 9. 3 cubed, that would be 27.
yeah.
But then 3 to the power 4, that would be 81. Right? I mean, I said for number 2, the answer would be negative 4. Lewis, it's not, so Lewis, it's not negative 2 to the power 4. It's 2 to the power negative 4, which is 1 over 16. So 2 to the power negative 4, that's the 1 over 16.
Oh, that's why it makes it a fraction. Gotcha.
Yeah, yeah. Mhm. Actually, negative 2 to the power 4, that would be
Yeah, that'd just be 16.
positive. Well, would be positive 16, yeah. So when you have like a negative power, that would give you like a fraction, right? It's because you flip, actually, it's like you flip this number, and yeah. All right, guys. So yeah, for number 1, so as Richmond said, so for number 1, this is your A, this is your base, okay, and this is your X. So the question is, for which power of A? So A is 2, so A to the power Y would be X. So for which power of 2? So it's like 2 to the power Y. Y is unknown, is equal to X. X is the 16. Okay, so that's so because 2 times 2 times 2, I mean 4 times, 2 multiplied by itself 4 times, of course 4 times, that would be 16, right? So then Y, your power, the answer Y, this number Y here, that's equal to 4, right? So then this log in base, so the answer, so log in base 2 of 16, that would be 4, right? So because 2 to the power of 4 is 16. And again, guys, it's, I mean, this is log in base 2 of 16, right? That will give you the 4. So of course, like if you have a different number, like log in base 2 of 8, then the answer would be 3, right? Because 2 to the power 3 is 8. So as I said, this is log of 16. So you cannot separate the log from the 16. You apply log in base 2 to the number 16, you get 4. You apply log in base 2 to the number 8, you get 3. You apply log in base 2 to the number 4, you get 2. Okay, so log of a number will be a number. Log itself, it's not a number. Okay. So the log is always the base. Yeah, of course. So use always this base here. Yeah, you have always a base. Yeah, of course. And that's the base of your exponential, right? This is, you see, this is exponential. 2 to the power X or 2 to the power Y. That's your exponential in base 2. Yeah. Yeah, there's always a base in the log. Now for number 2, we have, so this log, it's Y equals to log in base 3 of 1 over 81. Right, so that's, so the question is, for which power of 3, that's your base, the 3 is the base, for which power of 3 you're gonna get 1 over 81. Right, so this is the unknown here, of course, this is your Y here, which is unknown. But then you know that 3 to the power 4, 3 to the power 4, it's 81, right? But then your 81, it's not in the top. Your 81 is in the denominator, right? So if you want to get 81 in the denominator, then you need a negative power, right? So then 3 to the negative 4, that will be 1 over 81, Okay. So then the answer, of course, would be -4. So the y. So log in base phi of 1/81, it's -4. Number phi, it's log in base 4 of 1/16. So y is log in base 4 of 1/16. So for which power of 4, that's your base, for which power of 4, you're gonna get 1/16. Well, the relation between 4 and 16, you know that 4 times 4 is 16, right? 4 squared is 16. But then here, your 16 is in the denominator, so you need a negative power. So that's 4 to the -2. That's 1/16. Okay, and so then the answer, of course, would be, this is supposed to be your y, so the answer is -2. So the answer, so this log in base 4 of 1/16 is going to be equal to -2. Right? So anyway, so the idea here, guys, you see here log of in base 4, log in base 4 of 1/16, it's a negative number, it's -2, right? And in the first example, log, in base 2 of 16, that would be positive number. So a log of a number can be positive or negative, okay? It can be any real number. Or of course, it can be a decimal, it can be a fraction, it can be any real number. All right. Yeah, I forgot actually one more example. A very interesting example is when you have log in, let's say, base, any base, let's say 6 of 1. Okay. So for which power of 6, that's my base, 6 is my base. So for which power of 6, you're gonna get x, which is 1. So the power here, of course, is y. That's the unknown. So for which power of 6, you're gonna get 1, 0. So thank you. Yeah. So then, because 6 to the power 0, I mean, any non-zero number to the power 0 is 1. Okay. So then, yeah. So then log. So the answer. So log in base 6 of 1 would be 0. And this is like a very general statement. I mean, log of 1 in any base would be 0. Remark. So log in base a of 1, this is always 0. Okay. And that's because a to the 0, this is always 1. Okay, because the non-zero number to the power 0, that's always 1. That's why log of 1 in any base is 0. Okay. Yeah, so keep in mind, guys, log in any base of 1 is 0. All right, next. Let me add one more remark, because I think on Wednesday last week, I talked about the natural exponential, right? So this number, there is this number e. Now the log in base e, it's called the natural log. So let me, remember we talked about this number e. So there's this number e. There is a number. There's a number called the number e. Okay, which is, again, it's approximately 2.718, I think, etc. And what's so special about this number? As I said, so this number has very nice property, and which is so the derivative. So the function f, which is the exponential e to the x, okay, is equal to its derivative. So there is this very special number e for which the function, the exponential function e to the x, is equal to its derivative. As I said, I mean derivative. I mean you'll see this in Calc 1, but derivative is just like the slope of the graph. Okay, but anyway, so there's this special number e, like pi or etc. And as I said, so the exponential using this base e is called the natural exponential, and the corresponding log, so the log in base e, so the log in base e is called the natural log. Okay, natural log. And the notation for natural log, so log log in base e of x, it's actually denoted by ln of x. So this is ln, natural log. Okay, this is what I call natural log. Natural log. So this natural log is like this log in base e. This is like the most common log. It's very very useful. But anyway, so yeah, so that's what I call natural log. That's the log in base in base e. All right. Yeah. Now some properties of the log. So I'm gonna just remind you guys first. We have all these power rules. For example, 1, 2, 3, 4, 5. So for example, if you have like a to the power n times a to the power m, right? We said it's a to the power same base, so that would be a to the power n plus m, right? And if you have like a to the power m over a to the power n, so that's a to the power m minus minus n, sorry. So you see guys here, the power n, it's in the denominator, right? This power n. But then when you move your power n to the top, it becomes minus n, right? So that's exactly what I was saying. When you have like a power like in the denominator, let's say, and you move it to the top, then you have to change the sign. So if you have like, this is like supposed to be plus n, right? But then if you move it to the top, it becomes minus n, right? Anyway, so we have all these power rules. So this is for the exponential function. Now, because the log is the inverse, so this is consequence number 2. So because the log is the inverse, log is the inverse of exponential. Okay, then so the first property of the log is, so you see here guys, so what we are saying is the product of two exponential and the same base that will be the exponential of the sum of the powers, right? Okay, so the product of two exponentials, that's the exponential of the sum. Now, because the log is the inverse of the exponential, you're gonna get log of the product. So x times y, okay, that will be log the sum of the logs. So that's a log, or sorry, base a. So log in base a of x times y, that will be log in base a of x plus log in base a of y. And again, that's because here, this is the product of two exponential. That's the exponential of the sum. Here, the log of the product is the sum of the logs. Okay, that's because of the relation between the log and the exponential. So for example, so let's say you have log in base 2 of, let's say, 4 times 8. Okay. So what we are saying here is that, so that will be log in base 2 of 4 plus log in base 2 of 8. Okay. So then log in base 2 of 4. So for which power of 2, you're going to get 4. That's 2, right? So this is 2 plus, and for which power of 2, you're going to get 8? Well, that's 3. So the answer, it's 2 plus 3. So the answer would be 5, right? So because, 2 to the power 2 is 4, and 2 to the power 3 is 8. Okay, so then the answer is 5. Of course, you can just do, well, you can just compute this 4 times, you can say, well, 4 times 8, of course, is just 32, right? So for which power of 2 you're going to get 32? Well, it's actually to the power 5, right? So that's the answer is 5. Of course, you're going to get the same answer anyway. But this is like the first property of the log. So log of a product is the sum of the logs. Okay, so log of x times y, it's the log of x time plus the log of y. Of course, in the same base, the base a. So this is for the product, right? Now, when you divide x by y, so the log of x over y, number 2. So if you have log in base a of x over y, so when you had x times y, it's a sum. Now, if you have x over y, so it's going to be a subtraction. So it's going to be difference between the two logs. So that's the log of x minus, so this is log in base a, of course, of x minus log in base a of y. Okay, so for example, okay, so let's say you have log in base, let's say phi of 9 over 27. Right, so this is like phi is your a, of course, 9 is your x, 27 is your y. Okay, so if you want to use this formula, x over y, log of x over y, so then that will be log of x, so log of 9, so log of the top minus, of course, this is base 3, log of the top minus log of the denominator. Okay, now what's the log of 9 in base 3? So that's like saying for which power of phi you're gonna get 9. So that would be 2, right? So phi squared is 2. So this is 2, right? Because phi squared is equal to 9, right? Minus, and here, you know that phi cube is gonna be 27. So the answer here would be phi. All right, so then final answer would be -1. Okay. Or of course, well, instead of course, if you don't want to apply the formula, you can just say, or you can just say, you know, you can reduce this fraction, the 9/27. Right? You can say, well, this is, you can reduce this, you know, divide here the top and the denominator by phi. So that would be log in base phi of, well, actually you can divide both are divisible by 9, right? So actually you can divide here by 9. 9/9 and 27/9, right? So so that would be 1/27/9, of course, is phi. So that's log in base phi of 1/3. Okay, and so this is well, so then that will be equal to, you can say, well, for which power of phi, you know, you're gonna get 1/3, right? So that's, you know, phi to the power 1, it's phi, right? So but you have the phi in the denominator, right? So you need to flip. So that's a negative power. So then phi to the -1 would be 1/3, right? So then y would be -1, right? So the answer here is -1. Okay. Or actually you can say, well, we have this log and base 3, 9/27. And as I said, this is log in base 3 of 1/3. And so when you divide the x by y, so that's log of the difference. So that's log in base 3 of 1 minus, right? Because it's x over y. So that's log of x minus log of y. Okay. Now, what's the log of 1? Well, remember, guys, we said log of 1 in any base. Where is it? Right here. Log of 1, it doesn't matter the base. It's always 0. So this log of 1 here, this log of 1 would be 0. This thing here, it's just 0. Minus, now what's the log of 3 in base 3? Well, it's like saying, for which power of 3 you're gonna get 3? Well, it's power 1, right? So this is 3 minus 1. So the answer is -1. But anyway, you're gonna get, of course, it's always the same answer, right? It doesn't matter how you compute your log. The answer is gonna be always -1. Okay. So yeah, so what we have to keep in mind is that, so log of division, log of x over y, that's the difference between the logs. Log of x times y, that's the sum of the two logs, right? So here's an exercise for you. Exercise. So try to use, again, use the formulas. You know, the log of you know, x times y, as we said, that's the log of x plus, of course, base a plus the log of y, and log of x over y. That's the difference between the logs. So please try to use these formulas to compute the following. So one, so let's say you have log. So log in base 4 of let's say you have 16 over 64. And number 2, log in base 4 of 16 times 64. Richmond, you're saying for number 1, it's -1. Yes, absolutely. It's -1. Yes. Number 2 is 5. Yep, absolutely. Yeah. Yeah, thank you. Yes, so for number 1, it's log of 16 over 64. So the formula we need to apply here would be the second one, right? It's x over y. I mean, the 16, that'll be your x, and the 64, that'll be your y. Okay, so this is, again, so it's log in base 4 of 16 over 64. So this is supposed to be my x, and this is supposed to be my y. So if we use our formula, so that will be log in base 4 of x, which is 16, minus So this is minus because it's a division, right? It's a 16 over 64. So that's, you get subtraction. So it's minus log in base 4 of y. Y is 64. So again, this is your x and this is your y. Now, what's log in base 4 of 16? Well, so just remind you guys, so when I compute this thing here, this is y equal to log in base 4 of 16. So the question is, for which power of 4, you're gonna get 16, right? Right, so then the answer would be 2. So here, this thing here would be 2. So this is equal to 2 minus. Now it's log in base 4 of 64. So for which power of 4? So for which power of 4 you're gonna get 64. All right, so it's 4 times 4, it's 16 times another 4, that will be 64, right? It's 4 cube, right? So this is cube. So this number here would be 3. So it's 2 minus, so this number here would be 3, right? So it's 2 minus 3, and that will be equal to -1. Okay, number 2. So it's log in base 4 of 16 times 64. All right, so this is like your x. This is your x, and this is like your y. So it's log of x times y. And we said, so log of x times y, that will be the sum of the logs, right? The log of x plus the log of y. So it's a log of x. It's the log of x. So that will be log of 16 plus, right, because it's multiplication, then that will be a plus log of 64. 64. Now, what's log in base 4 of 16? So for which power of 4 you're going to get 16? Again, it's going to be 2 plus, and for which power of 4 you're going to get 64? Well, that's, again, it's going to be 3, right? So 4 cube would be 64. So that's 2 plus 3. And so the answer would be, of course, 5. So the answer, final answer is 5. Right, any question, guys? So log of x times y, it's log of x plus log of y. Log of x over y, it's log of x minus log of y. Now, if you have like log of x plus y, then we don't have, let me just remark one thing here. If you have like log of and base a, sorry. So log of x plus y, if you have something like this, okay, then we don't have any formula for this. There's no formula for this. Okay. Or if you have like x minus y, like log in base a of x minus y, same thing, no formula. There's no formula for log of x minus y. Okay, so you have to find another way to compute your log. Okay, so if you have x times y or x over y, then you have a formula to compute your log, but otherwise you don't have any formula. Okay. So yeah, there's one more formula. Actually, it's a consequence of the formula number number 1. There's one more formula, which is actually consequence. So this is just a consequence of log of x times y. It's consequence of log of x times y equal to log of x, as we said, plus log of y. So what's this formula? Well, so if you have log in base a, okay, of x to some power, let's say to the power p, okay, then this is actually equal to, so you can put the p, you can put the power in front of the log, so that will be p times log in base a of x. So if you have a log of some power of x, then you can always put the power in front of the log. Okay, that's because, so why this is true? Well, it's just because, you know, if you have log in base a of x to the power p, so this is like log in base a of x times x, you know, p times, right? X to the power p, that's like you multiply x by itself p times, right? P times here, right? Times x, p times, right? And then we said, you know, if you have a product, like if you have like log of x times y, that'll be log of x plus the log of y, right? So here we have like x times x, like p times. So that'll be log of in base a of x plus, right? Because we have a product, x times x. So it's log in base a of x plus log in base a of x, etc., p times, plus log in base a of x, p times, p times. So then that's p times log of x in base a. So this is, so the answer is p times log in base a of x. So for example, let's say I want to compute example number 1. Example 1. Let's say I want to compute log in base, let's say 2, okay, of let's say 8 to the power 5. So what I'm saying is that we can move the power to the front. So this power here, this exponent, you can move it to the front here. So that'll be 5. Okay. And then if you move the power to the front, then you are left with, so 5 times multiplication, right? Log in base 2 of 8. And what's log in base 2 of 8? Well, for which power of 2 you're gonna get 8? Well, that would be power 3, right? So then this is actually 5 times 3, which is 15, right? Because, you know, 2 cubed is equal to 8. So that's why here I got 3, because 2 cubed is 8. Example number 2. 2. So let's say you have log in base 3 of, let's say it's, let's say it's 1, or let's say here it's 27 to the power, let's say 4. Okay, so again, you can just move this power, which is 4, to the front of the log. So that's like 4 times, and then you are left with log in base 3 of 27. Okay, now that would be 4 times. Now what's log in base 3 of 27? So for which power of 3, you're gonna get 27, right? Well, that's power 3. 3 cubed is 27. So here, this is times 3, and then the answer would be 12. Okay. All right, so here's an exercise. So please try to compute the following. So 1. So let's say you have log in base 4 of, I mean, you can get like very large number, right? Let's say here it's a 64 to the power, 7. Number 2, log in base, let's say 2 of, let's say it's 1/8 to the power 8. So you're saying 21 for number 1. Yes, very good. And negative 24 for number 2. Yeah, very good. Yeah, very good. Correct. Thank you. Yeah, so so for number 1, it's log in base 4 of 64 to the power 7. So whenever you have a power inside the log, you can move the power to the front of the log. So this is 7 times, and then you have this log in base 4 of 64. So the question now is, what's the log in base 4 of 64? So for which power of 4? So for which power of 4 you're gonna get 64? Well, that's 4 squared, that's a 16. 4 cubed is 64. So this power here will be 3. All right, this is 3. So that's, so then you're gonna have 7 times 3, right? Which is, as Saul said, it's 21. For number 2, so it's log in base 2 of 1 over 8 to the power 8. I mean, the whole 1 over 8, it's to the power 8. Okay, so this is to the power 8. And again, you can, so we can put this power or this exponent in the front of my log. So that's like 8 times, and then we are left with this log in base 2 of 1/8 or 1 over 8. So the question is, for which power? Now it's for which power of 2? So this is 8. So for which power of 2 you're gonna get 1 over 8. One over 8, right? Of course, 2 cubed, that's 8. But your 8 is in the denominator, right? So then you need the negative power, right? So it's 2 to the power negative 3. That will be 1 over 8. Okay, so that's, so then the answer for this, that's negative 3. So we need to multiply the 8 by the negative 3. So, and again, so as the Saul said, the final answer would be negative 21.
24.
24, sorry. Yes. Thank you. Sure. I was thinking about the 7. Yes, thank you. Negative 24. Negative 24. Yeah. All right, guys. Yeah, so next, I think now we can start solving some exponential and logarithmic equations. So I'm gonna just move to the next, actually next section. So which is really important. So this is 3.4. So we're gonna use all these formulas actually to solve exponential and logarithmic equations. So we're gonna solve exponential and logarithmic equations.
Wait, Professor, I have a question.
Yeah, please.
So we're done with section 1, 2, and 3.
Yeah, I just combined. I combined the sections from 3.1 to 3.3. Right? Yeah.
Because our professor said the exam questions are going to be something like this.
Yeah, of course. Wherever I cover. Yeah, sure. Yeah.
Wow.
But as I said, I mean, the most important section in this chapter would be this one here, 3.4. So we're gonna use all our formulas actually to solve equations. Okay, so I mean, yeah, in the test or in the final, it's more about solving exponential and logarithmic equations. So we're gonna use our knowledge, to solve all the exponential and logarithmic equations. So let me start with exponential. I think exponential equations are easier than the logarithmic equations. So let me start with the exponential. Equations. So in the exponential equations, we're going to do a couple of examples, of course. So example one. So in the first example, let's say you have example one. So let's say we have 3 to the power, let's say 2x equal to 3 to the power x minus 4. So this is of course, we need to solve for x. So this is an exponential equation because, as you can see, your variable x is in the exponent, right? It's not in the base. So this is an exponential function. Yeah, I mean, both sides are exponential functions, right? This one here, this is an exponential function, because your x is in the exponent, right? Because x is in the exponent, right? Not in the base. Same thing here. This is also an exponential function, right? Because your x is the variable x is in the exponent. So that's why it's called the exponential equation, because you know, both and on the left and on the right side, in both sides you have an exponential function, and you want to solve for x. So the thing here in this first example, as you can see, we have the same base. I mean, in both sides, the base is 3, right? I mean, the base of the exponential function is 3, right here. So the base is 3 here. The base is 3, right? In both sides, we have the same base. So the idea, guys, like in this first example, when we have the same base, so here we have the same base. So when we have the same base, then actually it means that the powers are equal. Okay, so when we have the same base, then powers are or exponents, then exponents are equal. Okay, so in other words, the exponent here, it's 2x, right? The exponent here, it's x minus 4. And what we are saying is that, so because we have the same base, then we have the same powers. So these powers are equal. Okay, so then the 2x is equal to x minus 4, right? The exponents are equal. And now I can, you know, because I got rid of the phi, the exponential. Now it's just, you know, some linear equation, right? So I mean, this is 2x equal to x minus 4. I can, you know, you can just, for example, you can subtract x, let's say, from both sides. Then here x cancel out. So on the left side, it's 2x minus x, that's 1x. And on the right side is negative 4. So the answer, so the solution of this equation would be x equal to negative 4. So final answer is x equal to negative 4. Of course, as exponent, you can have, like, you know, some powers of x. So again, so this is example 1, example 2, number 2. Now let's say you have some power of x. So let's say you have like 3 to the power x squared, right? Equal to the 3 to the power, let's say 2x minus 1. Okay. So again, this is an exponential equation because obviously in both sides we have exponential functions. You know, your x is in the exponent, so that's an exponential function, exponential equation, right? Now, so how do we solve? Of course, you need to solve for x, and again, the idea is that you have the same base, right? Here's this is 3, this is 3, so it's the same base. And if it's the same base, then you can say, well, then the exponent is gonna be equal. What happened to the 2 in the first problem? Did I forget some 2? Where is it? You mean the 2x? Here's my 2x equal to x minus 4, but then when I subtract x from both sides, 2x minus x, that's 1x. You're talking about this 2x, right? The 2 and this 2x, right, Richmond? I guess that's the only 2 I see in the first problem, right? So the 2x is equal to the x minus 4. Okay, yeah, so then I subtract, when you subtract x, I got 1x. Yeah, okay, cool. Yeah, I was saying, again, here we have the same base, which is 3, right? And then the powers are equal. So this x squared is going to be equal to this 2x minus 1. So then x squared is equal to the 2x minus 1, right? Now, this is, I mean, you have x squared, right? So when you see x squared, of course, I mean, the highest power of x in this equation, of course, is 2, right? That's the highest power of x. It's 2. So that reminds you, right, the quadratic equation, right? So this is, if you just move everything to the left side. So for example, if you subtract, let's say 2x, and you add +1 both sides. So this is on the left, it's x squared minus 2x plus 1, which is equal to, of course, to 0. I moved everything to the left side, right? This is, 2x minus 2x minus 1 plus 1, of course, that will be this 0. So I moved everything to the left side. And as you can see again, so this is just the quadratic equation, right? With the x squared. It's quadratic because the highest power of x is 2. And yeah, and of course, when you have a quadratic equation, then you need to apply quadratic formula. So this is quadratic equation. And so we need to apply quadratic formula. So that's like, a minus b, plus or minus over the whole thing over 2a. Your b is, it's -2. So that's like minus -2. And then plus or minus square root of, b squared is -2 squared. That's 4. 4 minus 4 times a, which is 1, times c, which is also 1, over 2a, 2 times 1. So then your x is minus -2, that's positive 4. And then here, as you can see, this is just 4 minus 4, that's 0. And then square root of 0, of course, is 0, right? This is so 4 plus or minus square root of 0 over 2. Okay, so square root of 0, of course, is 0. So that's 4 over 2. So we have, so the answer, sorry, did I forget something here? Minus 4a. Oh, sorry, I wrote 2. I wrote 4 instead of 4. Sorry, here is, this is 2, of course. I don't know why I said 4. I mean, minus -2, of course, it's 2. So this is 2, of course. All right, so then the answer is 1. Yeah, so find answer. So the answer here would be x equals 1. All right, so this is like the first, this is like the first case when you have like the same base, then you can just say, well, the powers are equal, right? And then you can solve for your x. And then, of course, there's a second case where the base is different, right? So we have like 7 minutes. Okay. So so what I'm gonna do, I'm gonna give you an exercise, guys. So this is like so the next, of course.
Professor, can I
Yes.
see the other example for
Yeah,
a
sure.
second?
Yeah.
No, not that one. The one on top.
The example number 1.
Yeah.
Mhm.
Okay, thank you.
So of course, next would be, or the next question is, how do we solve exponential when we have exponential equation when we have like different base, right? But before that, let's just do an exercise. Exercise here. Exercise. So please try to solve for x. So 1, 2. So both are exponential equations, and so let's say here 1, you have like phi to the power 4x plus 1 equal to phi to the power minus phi x minus 2. Okay. Number 2, you have 4 to the power, let's say this is let's see, yeah, this is x squared minus let's say 5x equal to 4 to the power 4, just 4. Okay. And number 3, I'm going to use number e. So e to the power, let's say 2x minus 1. Okay. Is equal to, let's say 1. Okay. So let me just say, guys, in this exercise, in both sides, so we're going to have the same base in both sides. Okay. So in this exercise, so both sides have the same base. Okay. So next time, we're gonna solve exponential equations when we have like a different bases. Okay, so next time different bases. So let me just say for number 3, I mean, it looks like number 3, we don't have the same base, but we do. Here, 1, because you can write 1 as e to the power 0, right? Because, you know, any non-zero number to the power 0 would be 1. So 1, you can write 1 like e to the power 0. So as you can see, you're going to have the same base. Okay. Yeah, so the plan, so next time I'm going to show you how to solve exponential equations with different bases. And then, of course, we're going to discuss logarithmic equations. So we have like 3 minutes left. Well, I probably
Professor, can we
yeah.
go over this in class on Wednesday?
Yeah, I'm going to go over this on Wednesday. Sure, of
Okay,
course.
thank you.
Yeah, sure. Richmond, you're saying number 1 is 3/7. Let me see. Should be negative. Should be negative 3/7, right? Because you're gonna have 7x equal to 7x equal to -3. So it should be -3/7, I think. Yeah. All right, guys. You know what? I'm gonna stop here because, of course, we have just 2 minutes. So you can think about this exercise, and next time, of course, I'm gonna go over this, and then, as I said, discuss the case when we have different base, and then the logarithmic equations. All right. Thank you for listening, everyone, and I will see you in person this Wednesday. Okay. So we do have a class this Wednesday again. Okay. See you Wednesday. Take care, everyone. Yes.
I just wanted to make sure you got me for attendance. My name's
Louis?
Louis.
Yeah, I got you, Louis. Thank you. Appreciate it. Thanks.
Pastor,
Thank you.
Yeah.
See you Wednesday.
I
See you
wanted to
Wednesday.
make sure that the emails get through to you.
Oh
all the
yeah, yeah.
sheets.
I got it. I didn't have. I'm sorry. I didn't have time to grade your test, but yes, I got your test. Yeah.
No, because it looked like all the sheets didn't go through, but all the sheets did go through.
Okay. How many? Let me see. How
It's
many
supposed to
sheets?
be, I think, 7.
Okay. Let me. I'm sorry. I'm gonna just check. Let me
Yeah.
see. Okay. Oh, I got only. I think just 3.
3. All right. So can I see
Oh
which
yeah.
ones you got?
Yeah. Sure.
Because I was checking to make sure all of them went through. So I'm just gonna send it again.
Yeah.
Is that okay?
Sometimes this because of the size of the
The
file.
size of it? Okay.
Yeah.
No problem.
But it was just
Okay.
I got only 3. I guess yes.
What is it?
Only
The
3.
last pages or something?
Let me see. I got last pages. Yeah.
All right. So I'm gonna send the other pages.
Okay. Thank you.
Okay. Thank you.
Yeah, appreciate it. Thanks.
Mm-hmm.
All right, guys. See you Wednesday. Saul. Yes. Thank you, Saul. I got you. Thank you. Sir. Yes. And I'm gonna stop, I guess, recording.